and talk about angles. We have a graphic on the board, on your page and on the board, which shows us what we need to know about lines and angles on the SAT. So here's our little graphic here, and I'd like you to start. I just want to go around the room and do this chart on the top. Jordan, start with you. Can you read me the first box and fill in the answer?
Angles that make up a line are supplementary add up to 180.
Supplementary lines add up to 180 degrees. We need to use this concept on testing. Thank you, Jordan. So, Peter, which angles in this figure are supplementary? Give us some examples, please.
A and D, B and C.
Supplementary, they add up to 180. They make a straight line.
It's different how to do it.
I'm sorry. Do you guys not have A, B, and C and D next to each other like this?
C and D are.
A, B, okay. That's interesting. Okay. So what ones would be supplementary then?
A, D,
A, D, yes.
B, C.
B, C, yes. Okay, so the ones next to each other that make a line. That's very interesting that your book doesn't have it the same way. Okay, so which lines and which angles are then vertical? Okay, Jason.
A and C, B and B, E and D.
Good. So vertical angles are angles that are across from each other. And what can we say about vertical angles? More specifically, the measurements of vertical angles. That's congruent. They're congruent. So vertical angles are across from each other, and they are congruent. Thank you, Christopher. Okay, so when two parallel lines are intersected by a third line, what can you say about corresponding acute angles and corresponding obtuse angles? Matthew? What do you say about corresponding angles? They're congruent. They most certainly are. Those are equal as well. Okay, so which, everybody should know this. Parallel lines are notated with the symbol, everybody. What does the symbol look like? Make it with your hands. Woo, okay, it's got two lines that go up and down. Okay, good. So, Brittany, parallel lines have the same what?
Have the same.
Help her out, Rafat. What do parallel lines have the same what? We talked about this the last hour of class.
Same slope.
Slope. That's exactly right. Parallel lines have the same slope. Okay. So no matter how far you extend parallel
what the interior angles of a triangle equals 180 degrees?
It sure does. Thank you. Alrighty, and what does the area of a triangle equal, Peter?
1/2 times base times height.
It's 1/2 base times height. Thank you, Peter. Alrighty, so now let's move on to Christopher. What is an exterior angle of a triangle? I want everybody to write this when he says it because I'm not going to write all this down. What is it?
I don't know how to describe it.
Okay. Alrighty. Who does? Who can describe what an exterior angle is? Tasha.
What are we looking at supplementary angles that goes into the triangle?
Sure. It would be a supplementary angle. So this is what I want you to write. The exterior angle is formed when one side of the triangle is extended. Again, it is formed when one side of the triangle is extended. So in this sample triangle that I have drawn right here, the exterior angle would be here. It's not inside the triangle, it's outside as a supplement to one of the interior angles. Good. Okay, let's move on. In any triangle, a side opposite a greater angle is blank than a side opposite a smaller angle. So what relationship do you know about these sides? Yes. Jason.
Greater than the side, see?
Sure, it's longer. The sides opposite the greater angles are longer. So longer would be the word for that. Now in any triangle, sides opposite equal angles must then be, Jason.
I'm sorry, what?
I'm sorry, I should have identified you first. So if you know that the side opposite a larger angle has to be longer, what do you know about the sides opposite equal angles?
Very equal.
They're also equal. Okay, good. And any triangle sides opposite equal angles are equal. Okay, number 5. Can you take the next one, please?
A triangle with 2 equal sides and 2 corresponding equal angles is called an isosceles.
It is called an isosceles. Good. Alrighty. So let's take a look at the one across from it. Brittany.
The triangle with 3 equal sides and 3 corresponding equal angles is called an equilateral triangle.
It is called an equilateral triangle. And furthermore, what do you know about the measures of all the angles in an equilateral triangle? Always 60. Good, Brittany. Thank you. So they're always 60 degrees. Okay, but I have a volunteer to tackle the triangle in bisects ABC. So what do you think would be a reason that they would give you that information? What realization are you supposed to make as a result of that, Mitashi?
You can figure out what angle ABD and ABC are.
And what are they?
50 degrees.
They're 50 degrees each, and that is why they tell you that BD bisects ABC. But Mitashi, why do I care that these angles are each 50 degrees? What does that help me know?
You can add them up and then you get 110, so then you know that the other angle, angle ADB is 70 degrees.
Great. Okay, so now we've got everything we know. Now, let's go to the Kaplan method. What is the question asking us to find? Robert, what's the question asking us to find?
What is the measure of BDC?
They just want to know what is the measure of BDC. So, what theorems that we've discussed are going to help you to figure out the answer? What is the answer? Robert. Okay, that is the correct answer, but what are we using to figure out what it is? What idea? Tell me how you know.
I don't know how to do
Okay, well you're looking at angles, right? So explain to me what angle BDC is, what relationship you see in that figure. Does that have a relationship with any other angle? Julia, help them out.
You know that because BDA is 70, you know that BDC is 110 because of corresponding. And so equal, or they're not corresponding, they're adds 180.
They're supplementary. Okay, so you're using the supplementary angle theorem, Robert. Thank you, Julia. And it's the idea that you know that they're supplementary and they add up to 180, which I think you know that, you just didn't know how to verbalize it. As long as you can do it on the test, that's all that matters. Test day, what can you do on test day? And that's exactly right. You use supplemental angles, you know that that missing angle is 110. What answer does that match up with, Robert? D, that's absolutely correct. Okay, great, you guys. Let's go on to page 266. All right. So, with that, let's take a read of the top box and tell us what it says.
Right angles appear most often. Always look for hidden right angles within a congruous figure.
Absolutely. Remember, I mentioned that at the beginning. Triangles are very important. Right angles are very important. So, the Pythagorean theorem. Peter, you were talking about the Pythagorean theorem a little bit before, talking about how there was a variance of the Pythagorean theorem. What is the Pythagorean theorem?
A squared plus B squared equals C squared.
Absolutely. I'm going to write it this way, but you're absolutely right. You can also write it A squared plus B squared equals C squared. And what do these letters mean? Specifically, what does C mean? 4 radical 2 because she's simplified. Okay, so you can note that the legs are 4 radical 2. And I know it's not in your book, but it's just to show you that you can play with that in your own way. So now, let's take a look at number 3. And I want you guys to give me an answer fast. And I don't want you to do any math at all. Let's look at it. In the figure above, what is the length of BC? What is the question asking us to find? Christopher?
The length of BC.
So we're looking for the length of BC. We're looking for this one. Okay, so what information am I giving, Christopher?
The length of AB, AD, and BC.
Okay, you're giving all these lengths. So what am I going to do with this information?
You're going to use the Pythagorean triplets.
You're going to use Pythagorean triplets. How can you do that?
Well, since triangle ABD, the hypotenuse is 15, and one of the legs is 9, we'll tell that the second leg is equal to 12.
Okay, I set it up like this so everybody can see. Does everybody see that you have 9, then you have a leg, and then you have a hypotenuse, it's 15. And all Christopher noticed is that this is a multiple of the Pythagorean theorem, 3, 4, 5. And so if it's 9 something 15, Christopher, what must that x be?
12.
That must be 12. Am I finished?
No.
No, because that's not what the question asks us to find. It asks us to find this one. How am I going to know what that is?
Another Pythagorean triplet is 5, 12, and 13. So you can tell that since BC is a hypotenuse, it's equal to 13.
13. And that's the correct answer. And what letter does that match up with? B. That's absolutely right. Okay. So remember, using Pythagorean triplets is going to help us a lot. Okay, now let's go on to our final page on 267 and look at polygons. I'm going to start on this side of the room now. Julia, can you start reading in the first box?
A polygon is a closed plane figure formed by 3 or more lines.
Okay, continue because there was nothing to fill in there.
Every time you add a side of the figure, you add 180 to the sum of the interior angles. The sum of the interior angle measures the polygon with n sides equal to.
Okay, Julia, what's the formula? Okay, who knows what the formula is? Who wants to help, Julia?
N times 180.
Okay, that's part of it. Okay, you know what? This is a very complicated one, and I'm going to write it for you. The formula is 180 times n minus 2. Now, how are you going to figure that out? On test day, think about it this way. What is the sum of a triangle angle measured up to? What do they add up to? 180. How many sides? 3. So if the number of sides were 3, what would you get? 180. So it's just the number of sides minus 2 times 180. We use a triangle for an example. Okay, so let's take a look at the next box. Natasha.
Parallelograms are quadrilaterals whose opposite sides are parallel.
Well, yes, they're parallel. And what can you say about the measurements of them?
They're also congruent.
They're equal, that's right. They're absolutely parallel, but they're equal. That's what we want to get you to say. And then continue.
And whose opposite angles are also congruent.
They are. They're also equal or congruent. Okay, let's move on to the next thing. Brittany, next box.
The area of any parallelogram, including squares and rectangles, is
What is it?
360.
The area of a parallelogram. What's the formula? Like a rectangle, for example. Yes, or base times height. Exactly. Length times width, base times height. Good. Okay. The diagonals in a parallelogram. Okay. Diagonals in a parallelogram. The idea of a diagonal is something that goes across like that. Now, a diagonal will intersect and bisect each other. Think about this. You have 2 diagonals, they intersect and they cut each other in half. So the diagonals will intersect and bisect. Okay, trapezoid triangles that make up the